Hi, and welcome to my workshop here in Sheffield, England. It's a very cold night. On my bench will be two Philco model 48420 radio receivers, very kindly given to me by my good friend Brendan from across the pond, way down in Detroit, Michigan. You might agree they are, for their age and for the amount of service that they have given, in fairly decent condition. So restoring them should not present any problems. Right, it's time for me to get started. These two Philco Hippo model 46420 radios, introduced onto the United States market during 1948, were very kindly given to me by a very dear friend of mine, Mr. Brendan Dadle. He sent them across the pond to Sheffield from down in Detroit in Michigan. I'd been on the lookout for years for a Philco Hippo. They occasionally crop up at vintage radio fairs here in England, but their ticket price was always beyond the content of my wallet. So, a massive shout out for my good friend Brendan. Thank you, mate. You've done me proud. Now I'll turn them round so we are facing their rear. As you may well have spotted, the radio on the right has only a 2-inch stub of mains lead. Its frame aerial is missing, and so is its back cover, but very doubtful they will pose a problem. I'm quite sure replacements can be fabricated. The radio on the left looks to be intact. Its moulded cabinet has sustained damage at some time in its history. There is a chunk of Bakelite missing from the bottom left rear corner, and it has developed into a crack through to the front bottom left corner. I have downloaded a circuit diagram for this model, and I'm developing a positive feeling about these two radios. Give me a few minutes to remove the chassis from their respective cabinets, and we will take a good look at them together. Before going on to remove the chassis from their respective cabinets, I have a feeling some of you will find this interesting. Prompt Radio Service Call, Joseph Ardner Radio Service, phone GA 9090 2213 LaGrange, Toledo, Ohio. Shut up. We specialise in Sylvania radio tubes. This, my friends, places a human aspect to this radio. I own hundreds of radios, and beyond the manufacturers and how I came to own them, I do not know anything specific about their history. Yes, I like that little touch. When these radios were in transit, my friend Brendan described them as both being farm fresh. Given their age, both chassis are quite tidy, especially when compared to some of the radios that have been on my bench. Most of those were absolutely disgusting, which was not surprising since a large number were rescued from factory and colliery buildings that were about to be demolished or in the process of demolition. Inside one or two of those rescued radios, I discovered the remains of expired mice. Definitely not pleasant. As I say, these radios are quite tidy by comparison. The 35Z5 rectifier on this right hand chassis has open circuit heater. I feel fairly sure there are at least a couple of those spare type of rectifiers downstairs. If not, I can send off for one. And the TS44 dial lights on both radio chassis, they both read OC. Then again, getting hold of replacement types should not be a problem. A mix of 4 B8G type valves and 2 octal valves is quite interesting. I'll talk some more about those later. I'll flip these chassis over so as we can take a look at their underside. As far as the componentry goes, under this chassis on the right, it looks to be unmolested. The reservoir and smoothing capacitor canister on this chassis to my left has been replaced at some time. I must say here, I generally do not have any problems with previous repairs. I don't let them bother me. In this particular instance, the person, presumably it was a service tech, did a first-class job when fitting that capacitor canister. That person did the job right. They anchored the canister to the chassis. How often do we see components, especially larger components like capacitors, bobbing about in mid-air? Plenty of connecting wire has been left for manoeuvrability. There's nothing worse, in my opinion, than bunches of tightly packed wires, and you are spending valuable time looking at circuit diagrams and using your multimeter to determine the required wire or which wire goes where. In this instance, the 3 connecting wires need to have been quite so long. I suppose I'm nitpicking here. As I have said, a superb job. Right, chaps, I'm not going to muck about. Each and every one of the paper and foil capacitors valued over 1 nanofarad will be replaced with new, and each resistor value will be checked. If out of tolerance, they too will be replaced. Pretty much a standard approach. Right, I will be back shortly with a progress report. In my usual style, I am fabricating 2 small printed boards and brackets from these strips of aluminium, onto which I will fix the reservoir and smoothing capacitors, and in this instance there will be a larger capacitor. I shall explain that a little later. Okay chaps, brackets for holding the printed boards are now done and dusted. There is one for each of the radios. Brackets like these are very simple and very easy to make. I used 1.5mm thick aluminium. It was straightforward to measure, cut and file. Next to no skill required. This is how they will be mounted onto the radio chassis. Just there. I'll fit the other one on. And that's the other one. Just there. Right, all I need to do is plot the print, etch in ferric chloride solution, drill holes where required, solder 3 capacitors onto each board, wire into the radio circuits and secure onto each chassis. And it is no more complex than that. Off camera I'll get on with all of that. The print has been plotted and drawn onto these boards. They are in the ferric chloride etching solution. I shall keep this container gently rotating until the exposed copper has been etched off those boards. Remember the rules concerning disposal of hazardous substances like ferric chloride. It should only be done within the guidelines of local authority or government. If you are following along with this process, you are doing so at your own risk. Here are the 2 printed boards. Each populated with the reservoir and smoothing 22 microfarad electrolytic capacitors that were housed in a cardboard tube like this one just here. Part identification as printed on the circuit diagram is C15 and C14 with the series choke, which value is 220 nanofarad for the floating negative to Derco chassis, is also soldered onto the printed board. The 22 nanofarad capacitors are both X-rated. The small printed board is now secured onto this chassis. It's quite sturdy and it will be durable for many years to come. It is connected into the circuitry of this radio, and it's good to go. I've fitted a length of mains lead. You will recall its original lead had been severed. This mains lead was salvaged off an old Alba record player from the late 1950s. As I recall, Stindl insulated mains lead such as this type is no longer regulation here in the UK. It hasn't been since 1975. It is, at least for the present, as far as I'm aware, suitable for 117 volt AC equipment. Since the UK does not, or at least as far as I'm aware, it does not supply 117 volts domestic AC supply. It's not part of the UK's national grid. There again, as far as I'm aware. The only way this radio can be powered is via a step-down transformer, so there is no chance of a live chassis. It does not matter which way round the mains plug is inserted into a socket or receptacle, which reminds me I must send off an order for half a dozen American mains plugs and a small drum of black and white double insulated mains lead. I must do that. Taking a notice of that last bit, I'm excuse me, I'm thinking aloud. So, what is left to do on the underside of this chassis? Well, there are two remaining resistors to check. A 15k by the look of things, and a 2.2 meg. Both are carbon composite types. All the other passive components, i.e. resistors and capacitors, have been checked and replaced where necessary. Right, I'll get on with checking and then I'll get back to you. This concludes checking and replacing passive components where required on the underside of this chassis. What looked like a 15k carbon composite resistor was, or as I should say, a 3.3 meg resistor. I didn't need to check it. I broke it. I broke it as I was unsoldering it off one of this valve base pin terminals. Yes, I will hold my hands in the air and admit I'm always breaking something or other. Sad to say, it's just me. Something I've done all my life. I'm not proud of it. But I'm not always clumsy. I removed this 2.2 meg carbon composite resistor without breaking it. And it happens, this resistor measures 2.9 meg. being way out of tolerance, and also being a cigar-shaped variety, it had to go. Both the 3.3 meg and the 2.2 meg carbon resistors have been replaced. I'll now go on to flip this chassis over and do an inspection of its top side. Apart from a little dust, the top side of this chassis does not look too bad. Compared to some chassis I've worked on in recent weeks, it looks quite decent. The first job I'll do is replace this defective 35Z5 rectifier valve. Note what is printed on the Bakelite glass holder. When renewing, insist on a genuine Philco tube. Now, one RCA Radiotron valve is just as becoming. In all truth, I don't possess a genuine 35Z5 Philco tube, so the RCA valve I just fitted will have to suffice. There is a 1.5 nanofarad wax coated paper and foil capacitor just here. That will be replaced with this Mullard branded 1.5 nanofarad capacitor. The frame aerial is missing. I'll temporarily commandeer the frame aerial off the other Philco Hippo for test purposes. If I can't find some other frame aerial off another type of radio, which I suspect I won't, I'll have no alternative other than to wind a replacement type. In the meantime, I'll replace this 1.5 nanofarad capacitor back shortly. Having fitted the 1.5 nanofarad pad capacitor and borrowed the frame aerial from the other Philco radio, it was time to connect this wee radio chassis up to a 117 volts AC supply and switch on. I didn't bother connecting into a variable transformer or dim lamp limiter. I had a good feeling this was going to function okay.
Very well and on belly. The Spurs today took up some intelligent position. Google G5G. First job post and get seen by more quality candidates. Our reduced menu, and we'll start preparing them when you're nearby. Nice. From 11 AM to 10 PM. Participating restaurants only. App T's and C's apply.
Right. it certainly works okay. There's that little radio, despite the fact that the speaker cone is punctured. But I'll sort that out a little later on. Right, I'll move over to the other Philco Hippo radio chassis and I'll quickly assess the situation. I feel pretty sure it's going to be a carbon copy of this chassis. We shall see. And here before us is the other Philco Hippo radio chassis. It's not my intention to make a meal of replacing wax-coated foil and paper capacitors, along with checking and replacing, where appropriate, carbon composite resistors on camera. As you are aware, I've fabricated a reprinted board, so I have. That houses the reservoir, smoothing and floating chassis capacitors. Once I have installed that printed board, I'll work my way through the underside of this chassis like a dose of salts. Once I have done that, I'll get back to you. Right, that is the components checked and replaced where appropriate for the circuitry of the 50L6 GT. Now it's over to the components checked and replaced where appropriate for the circuitry pertaining to the 7C6. It doesn't take me long to break something. A 2.2 meg resistor. It was fine until I got hold of it. I do have a replacement, so no worries. 2.2 meg broken resistor has been replaced. Let's see what I can break on this side of the chassis. Now, this second of the two Philco radio chassis is now working. To get it working was pretty much similar procedure done to the first Philco radio chassis. In other words, more or less, what was done to the first radio chassis was done to the second radio chassis. In this particular instance, I discovered two defective valves. A 7B7 and a 7C6. They have been replaced with Cossa branded type of valves. Right, we'll demonstrate this radio. We've just got to wait for all 6 of the valves to warm up. Right, here goes.
Pembrokeshire Police say they and the Coast Guard have denied it's a hijacking. Bob Seeley is the MP for the Isle of Wight.
Struggling for real obvious goal-scoring opportunities.
Even if we haven't seen each other in ages.
On me like that. And yes, we bring Bucky's.
Mackies round the corner.
And then.
Mexico, kebab.
And then.
And that is the entire travel of the tuning capacitor. Right, this radio, like the other radio, is quite sensitive, and it doesn't sound too bad considering its speaker cone has sustained a long tear from one side through to the centre, and from the centre to the other side of the speaker basket. and also the outer cardboard gasket has fallen off. But we'll not let that worry us. Right. You'll see I've devised and constructed an alternative dial light. Using 2 bright white LEDs and 3 resistors. Here is my scrappily drawn diagram. As you can see, it is nothing remotely complex. A 220 ohm surge limiting resistor in parallel with 2 470 ohm feed resistors and 2 LEDs in opposing forward bias configuration. I'm not going to dwell upon this LED dial light arrangement since there is little to talk about. It is what it is. I'll get to repairing both speaker cones in part 2 of this restoration series. In the meantime, I'll progress on to fabricating a replacement frame aerial. Now, my stocks of enamelled copper wire are somewhat limited. The closest I have to hand is 26 SWG type of wire. It's the closest I have. This original wire that is forming the frame aerial looks to have been constructed from 24 SWG type. The only immediate option I have to construct a frame aerial is using the wire that you saw a couple of seconds ago. I think we will be okay. I have a shrewd feeling that it will suffice. As I say, we shall see and hear. That's all we can do. Catch you in a little while later. Before getting into assessing the requirements for constructing the frame aerial to suit a Philco model 46420, I felt it necessary to remove the tuning dial and cursor arrangement on this cabinet. As you will see, the original frame aerial was adhered all the way around the inner rear of this Bakelite cabinet. By removing the dial and cursor mechanism, I not only minimise the risk of breaking anything, which, as you have observed, I'm prone to doing, I also require as much space as is permissible. Also, whilst the dial and cursor mechanism is out of the Bakelite cabinet, I have access to cleaning as well as spray painting. I will stress at this point, when removing circlips from Bakelite nodes, patience is definitely a virtue. Breaking a Bakelite node is very easy to do. It takes no effort. Removing the dial and cursor arrangement took almost 15 minutes. The two circlips were very reluctant to budge. Eventually, by applying with a careful amount of pressure, both clips yielded. So patience eventually paid its dividend. That part now accomplished, and the cursor and dial arrangement stored safely in this plastic receptacle. Off camera I'll go on to assess what will be required for constructing a replacement frame aerial. Long before arriving at where I am now with this radio's restoration, or reconditioning if you prefer, I'd made up my mind I would not be gluing and winding enamelled copper wire round the inside of the rear of this cabinet, though I've seen others successfully applying that approach. I've tried doing that, at least 4 times as I recall, and on each occasion I came unstuck, pun intended, since I failed to get the windings to adhere to where I wanted them to adhere. For whatever reason, I felt to have been, on those occasions, lacking the required dexterity. Be that as it was, I found wrapping thin card all the way around the edge of a template and then gluing enamel copper wire direct onto the card. When glue was dry, I then transferred the frame aerial to the inside rear of the cabinet and secured it there with a decent brand of impact adhesive. Over the decades I've applied that method, and I'm happy to say it has been successful on each occasion. So I will do that. Right. Where's the... Yes, it's here. With a very sharp pencil, I marked out the shape or profile of the rear opening of this cabinet. Right, there we go. There. Right. And I cut out this template. It's just a scrap piece of MDF. It's about 20 or so millimeters thick. Using a jigsaw, I cut that out, and as can be seen, it is too large to go into the rear orifice of the rear of this radio. So I will use very coarse abrasive paper so I can reduce its size to not only fit the rear orifice of this cabinet, but to also accommodate the frame aerial. Off camera I will quietly get on with that task, so I will. And here we go, chaps, profile constructed, or shape to fit into the rear of this radio's cabinet. There is no need, of course, for it to resemble a work of art. I've made provision for the thickness of the frame aerial by allowing a 2mm gap all around its edge. As can be seen, it fits into the rear of this cabinet quite well. Rather than using stiff card, I've decided to use masking tape, something I've not done before. Hopefully it will turn out okay. Right, I'll begin by winding the required turns of copper wire, and I'll glue it into place as I go along. Right, that is the frame aerial now wound onto the profile. It's not the finished article, but it's getting close on to being the finished article. Right, I'll do a little bit more. I'm sure you will agree, although this frame aerial looks the part, when we assess how effective it is, the proof of the pudding will be in the eating. I've connected this radio chassis to 117 volts AC, and I've switched on. I will tune or rotate the ganged tuning capacitors one way through their travel. You can judge for yourselves how effective my newly constructed frame aerial is. I've temporarily left it on this profile to avoid potential damage. Right, here goes. Excuse the substandard audio output reproduction.
There we go, and the message contains: Hi Gary, my sister Kirsten had already... It's a loss of vaccine, that's your behind the points for it.
So talking to you then, hearing your story.
I know, it says delivering.
Goodness gracious. As I stated a while ago, the loudspeaker cones belonging to both radios have sustained cracks at some time in their history. Not that that is going to hinder my restoration progress. Each speaker cone will be repaired in part 2 of this series. Before that, I'll finalise part 1 with a synopsis of what has been accomplished thus so far with the 2 Philco chassis, and relate it to the circuit diagram. As you are aware, my modus operandi is to commence electronic servicing by sorting out the power supply circuit. By doing that first, I'm able to power the rest of this radio circuit. I need all the valve heaters to function, purely because I want all the valves to function. I not only require each individual valve heater to provide meter continuity, I also need continuity starting from the 117 volts live input and continuing via each valve in the heater chain, and returning to the 117 volts neutral supply via the mains on-off switch, operated by rotating the volume control shaft. As you will see, the 35Z5 half-wave rectifier heater is in 2 sections. One of them is a fuse in series with the dial light, and it also connects direct onto the rectifier anode. When it is sufficiently warm, it will conduct, and rho DC will be present on its cathode. Electrolytic capacitors marked here as C15 are two 22 microfarad at 400 volts working. They flank the speaker field coil, which is also a smoothing choke. From there, smooth DC, or as smooth as it is possible to get in these types of power supply circuits, is ready for use by the rest of the stages or sub-circuits incorporated into this radio. Right, we will take a look at the two radio chassis and see what I've done in relation to what I've just been talking about. There's not a great deal to see really. Each of the 6 valves heaters are connected in series. That is known as the heater chain. From pin 5 of the 35Z5, a wire goes off and connects onto the dial light. From pin 8, a wire connects up to this printed circuit board that I made, onto which I populated with the reservoir and smoothing capacitors, along with C14 for the purpose of isolation or providing a floating chassis. Right, it's now back to the circuit diagram. From the power supply circuit, I made my way over to the audio output circuit. I will state here, due to the nature of paper, foil and electrolyte and their reactions to one another over time, I am not going to go into all of that in any great detail, since it is beyond the scope of my synopsis or very brief account. But all capacitors over the value of 1 nanofarad were automatically replaced. Now, I am not implying capacitors below the value of 1 nanofarad do not become defective, because they do. I replace them as and when I find one tests as being defective, which is not too often. Now, going back to the 50L6 audio output, C17, a 10 nanofarad coupling capacitor, and C18, a 22 nanofarad top coat or tone enhancing capacitors, were automatically replaced. C16, which is a 250 picofarad, read fine on both chassis, though I've since noticed on one of the chassis the corner of one of those capacitors is chipped, so I might have to replace it. Now, R6, which is 130 ohms cathode resistor, gave a very high reading on one of the chassis. It was replaced with a 120 ohms carbon composite resistor. Well, what is 10 ohms between friends, eh? These types of circuit in any case are very forgiving. Right, on the other chassis, the R7 470k Grid 1 leak gave a value far higher than 20% tolerance. So that too was replaced with one that read pretty close to 470k. Now, given my luck over the past few months concerning transformers and chokes of various sorts, I checked the credentials of the audio output transformers on both chassis. Mercifully, they read as being fine. Again, there's not a great deal to see really, just here. I said only one of the 470k grid leak resistors was replaced. I see here the 470k's were replaced on both chassis. I'm getting them mixed up with the 7C6 anode feed or load resistor, which happens to also have a value of 470k. Talking of the 7C6 triode diode valve, I'll swiftly move from the 50L6 described in this RCA receiving tube manual as a beam power tube to the first audio or audio output driver. The 7C6 valve serves three areas within this radio's entire circuit. The first audio stage, demodulation, and automatic gain control, or AGC line. C20, which is a 10 nanofarad coupling capacitor from the slider of which is R12, the 470k log volume control, has been replaced on both chassis. R10, 3.3 meg grid leak was found to have been excessively high value reading on one of the chassis, so I replaced it. As mentioned a few minutes ago, I replaced anode feed or load resistor R8, 470k on one of the chassis. I can't remember the value reading that it gave, but when I tested it, I remember that it was excessively high. Now, as I usually do, I'll leave the AGC line until last. As seen on these two chassis, there's not a great deal to see really, just as before. That is associated with this MC6 first audio stage circuit. Apart from the 3.3 meg grid leak resistor replaced on this chassis, and the 470k anode load resistor replaced on this chassis. The two chassis, with regards to this stage, look pretty much identical. Right, it's now over to the 7C6 RF amplification stage, and it's over to what is commonly termed as the front end. I don't intend to labour this part or section of this radio circuit. There are a number of YouTube videos that explain the operations, including one or two of mine. So all I'll do here is skip through it just like I did on the previous three circuits. Now 7C7 is a sharp cut-off RF amplification pentode valve. Signals pass onto its grid 1 via C20 100 PF capacitor. It is amplified, but not to a great extent. It is regulated by the AGC line. So we don't want this RF amplifier to cause instability, especially at higher frequencies. From its anode, the enhanced signals are fed into the primary of what looks to be T6. The print is not so good. RF transformer, and it is inductively coupled to its secondary, which is also regulated via the AGC line. It continues to grid 4 of the 7A8 frequency changer valve. From its grid 2 downwards, it deals with the local oscillator. Its variable capacitor, C2, is ganged with C1. RF amplifiers and frequency changer circuit arrangements often incorporate a 3-ganged set of tuning capacitors. Not so in this radio. From grid 3 upwards, the signal is mixed as well as amplified, though it is not in any way prolific. At its anode there are many signals. The one that will become of interest is 455 kilohertz. That is the higher frequency. From the secondary of T2, first IF transformer, the signal passes onto grid 1 of 7B7. That is a remote cut-off pentode valve, which is the RF amplifier, and that is exactly what it does. Returning to the 7C6 diode triode valve, the signal is demodulated for audio purposes. Also, from the diode section of that valve, the AGC line is foam, starting from R11, which is a 2.2 meg, and time constant capacitor C12, 47 nanofarad, thus regulating the control grids of 7C7, 7A8 and 7B7 valves. And that is it, in a tiny nutshell. Right, we'll take a final look at the two chassis once again. And here they are, a quick final look for part 1 of this series. Like previously, not a lot going on, apart from the foil and paper capacitors that have been replaced, along with a 1 meg resistor replaced on this chassis, and a 120k replaced on this one. Other than those few components, these two chassis look pretty much as they did before. Certainly nothing of any great excitement. Indeed, that was that in a tiny nutshell. Thank you for watching part 1. In part 2, I'll be repairing the speaker cones, cleaning the chassis, spray painting one of the cabinets, and fabricating a back cover for the one that is missing. If you enjoy watching my videos, please like, subscribe and share. I thank you very much for your time and interest. It is very much appreciated. Please join me again for part 2. TTFN Phil.